Good morning. Thank you, Akhila, for inviting me. And thank you, Professor Balakrishna, for that very gracious introduction. As has been mentioned, I am a rehabilitation physician, and I work for people who have lost their limbs. More than 1 million people worldwide lose their limb every year. 80% of them live in the low and middle income countries. Even in India, of the 21 disabilities, locomotor disability tops the list in terms of prevalence. Now, according to the World Health Organization, only 5 to 15% of this 80% living in the low and middle income countries have access to prosthetic services. If the situation is so appalling today, you can imagine what it must have been like 50 years ago. At that point in time, there were practically no prosthetic services in India, and it was this total absence of prosthetic services that triggered the invention of the Jaipur foot. Now, Professor Balakrishna presumed that all of you would know what the Jaipur foot is, but I'm quite sure that there will be people here who don't know about it. So let me introduce the Jaipur foot to you by a quote from the Time magazine. The Time magazine says that people living in the many war zones of the world, from Afghanistan to Rwanda, may never have heard of New York or Paris, but they are likely to know of a small town in northern India called Jaipur. Because Jaipur is the birthplace of the extraordinary artificial limb called the Jaipur foot that has revolutionized the lives of millions of landmine amputees. So how did this come about? How did the Jaipur foot get where it did? So a group of doctors and craftsmen in Jaipur, SMS Hospital, decided to work on a solution for amputees. Because at that time, if somebody had an amputation, it literally meant that they would be confined to their homes for the rest of their lives. So they started on the premise that the reason we did not have artificial limbs in India was because they were expensive. And that's a line of thought many still pursue. And the solution they thought that would work would be to get artificial limbs that were being used in the West, make inexpensive replicas, and provide them to patients. And that's exactly what they did, procured artificial limbs from England, made inexpensive replicas, and very enthusiastically gave them to patients. However, this enthusiasm was very short-lived, for the patients rejected those artificial limbs and went back to using their crutches and sticks. So why was it that what worked so well for amputees in the West was a disaster for Indian amputees? So let's see what was the design that was replicated. So this is the SACH foot. SACH is an acronym for Solid Ankle Cushion Heel. And you can see the dark portion that I've highlighted is a wooden keel that goes across the foot. And as the name suggests, it's a solid ankle, which means it does not permit any mobility. Now, who were these people who were using this foot and were happy with it? So let's look at the profile of amputees in the West. A typical amputee in the West is over 60 to 65 years of age. They've lost the limb because of vascular insufficiency with or without diabetes. At that age, they also have multiple comorbidities, as a result of which their mobility is restricted and lifespan is short. The lifestyle of these amputees is such that they walk on level surfaces, they sit on chairs, and they always wear shoes. In contrast, what does an amputee in India look like? An average Indian amputee is a young, healthy man in the age group of 20 to 30 years who unfortunately met with an accident and lost his limb. He has no medical dysfunction pulling him down. and his whole productive life is ahead of him. Most of our amputees come from rural backgrounds. So they're required to negotiate rugged terrain. They sit on the floor, as many of us in the cities do too, and they may or may not wear shoes. Clearly, the same solution could not have worked for two such diverse groups. But I can say that in hindsight. Coming back to the satch foot, why did the satch foot not work? It's a solid ankle foot. It does not permit any mobility at the ankle. As a result, people cannot sit on the floor. They cannot negotiate rugged terrain. It does not even look like a human foot. It looks like a shoe last, so it has to be concealed within a shoe. With a shoe, people can't go into their farms where there's mud and water, and you can't enter a temple or a mosque. Realization thus dawned that designing a prosthetic device was not merely a technological concern, and that the socio-cultural, economic, environmental, and religious needs of the end user had to be taken into account too. It was then decided that we needed to make prosthetic designs that met the specific needs of Indian amputees, which were formulated as, let's make a foot that looks like a human foot, a foot that permits dorsiflexion so people can squat, a foot that has inversion and eversion so that people can negotiate rugged terrain without the ground reaction forces being transmitted to the stump socket interface. The foot should be waterproof and durable. It should permit use with and without shoes. It should be made of locally available materials. And of course, when designing for low resource settings, affordability always has to be woven into the design. So after many years of work, the design that developed was called the Jaipur foot. And you can see it's almost human. The internal structure of the Jaipur foot, exactly like the human foot, consists of 3 blocks: the ankle block, the hind foot, and the forefoot. The ankle block is made of wood because it is required to anchor it to the shank. The hind foot and forefoot are made of layered microcellular rubbers of variable density. The 3 are reinforced with tire cord and then encapsulated in a skin-colored cushion compound for the cosmesis. This is a section of the Jaipur foot, and you can see that the wooden keel that was there in the satch foot has completely been done away with. Now, although the Jaipur foot is a non-articulated foot, by virtue of the variable density of the materials, the layered composition of the hind foot and forefoot blocks, and the material properties of rubber, it permits mobility in all 3 planes. In fact, it is the only non-articulated foot in the world that permits this kind of mobility. As a result, people can squat, sit cross-legged, they can climb trees, and here you can appreciate the dorsiflexion at the ankle. They can even jump off trees, not that it's required, but since it's rubber, it'll take up the ground reaction forces and the impact, so they can do that, and they do. We have all kinds of patients who attempt things that we didn't even design the foot for. Ride a bike. You see, the Jaipur foot is a universal foot. The limits are set by the user, not by the design. The reason we wanted it to be usable with and without shoes, and why I mentioned that religious considerations had to be taken into account, was because people can go into the church with shoes, but we cannot go to the temple and mosque without taking off our shoes. And that's a very integral part of our lives, and we didn't want to keep our patients out of it. This foot was designed by an exceptional team of doctors with no formal training in biomechanics or prosthetics, craftsmen with rustic tools, and all the material know-how about rubber came from the roadside tire retreading shops. So it was extraordinary. This foot was studied at the Royal Liverpool Hospital by none other than Professor Kleineman. I don't know how many doctors are here, but Professor Kleineman is an authority on the human foot. The study compared the Jaipur foot to the two most widely used prosthetic feet in the West, the Satch and the Seattle, and they continue to be the most popular designs even today. They studied 4 parameters, 2 shock absorption and 4 gait style. The study was published in the International Journal of Prosthetics, and the conclusion was the Jaipur foot was found to be both functionally and cosmetically closer to the human foot as compared to the Satch and the Seattle. Now, Jaipur foot is open source, so anybody can make it. But the Jaipur foot made by the Jaipur Foot Organization, BMVSS, conforms to the Bureau of Indian Standards and currently is the most widely used prosthetic foot in the developing world. The second part of a prosthetic limb, a lower extremity prosthetic limb, is the socket and shank. Now, across the world, people use polypropylene sheets to make thermoplastic sockets and shanks. At BMVSS, the Jaipur Foot Organization, we pioneered the use of high-density polyethylene pipes. Now here, we take a cylindrical pipe, heat it, and convert it into a cylindrical limb. What we get is a seamless socket, and you can see that it's so lifelike. And because it is skin-colored, it obviates the need of a cosmetic cover, which is still a weak link in the prosthetic components across the world. This is Dilshad. She's from Kashmir. She lost both her limbs in a freak accident. She comes to us every 3-4 years for repair or replacement.
Hello.
This slide I made of random patients the day before I was coming for this conference. That was the very day they were fitted to those limbs. And if they didn't have their trousers rolled up, I'm quite certain you would not have been able to make out the limbs. She needs no introduction. Sudha Chandran made the Jaipur foot a household name. Now, Sudha Chandran can afford to use the most expensive prosthesis available in the world. In fact, international companies have been approaching her to try their prosthesis, which she did, but she continues to use the Jaipur limb. Now, if you have seen her on stage, which it's quite possible, then I shouldn't even be here trying to talk to you about the merits of the Jaipur foot, because you would have seen it in performance. As scientists, we want to quantify everything. Subjective opinions are not given the credit they should be. But as a clinician, and also as a scientist myself, I believe that validation like hers means more to me than any gait lab study, any certification, or ISO testing. Sudha Chandran is our brand ambassador and a personal friend. The next component of the artificial limb is the prosthetic knee. So, as you have seen how well our transtibial or below knee patients are walking. So we felt we had nearly gotten our act together for below knee amputees. But we were struggling with patients who'd lost the limb from above the knee. Anyway, the key distinction in lower limb amputations is whether or not the knee joint has been preserved. Because loss of the knee joint profoundly impacts the outcome. A person who's lost the limb from above the knee consumes 65% more energy than a normal person and is 54% slower than a normal person. In fact, a person who loses both the limbs from below the knee, which is bilateral TT, has greater efficiency than somebody who's lost one leg above the knee. Traditionally, all transfemoral amputees in India and across the developing world were fitted with single-axis knee joints with or without a manual lock, largely because of non-availability of better options. Now, the gait with this single-axis knee joint, person walked with a stiff knee, which was ergonomically inefficient and cosmetically awkward. So we decided to develop a high-performance knee, which was also affordable, and we did that in partnership with the Stanford University. Again, we laid down the design requirements, which were the knee should be stable in stance, that is when the leg is loaded. It should have good swing phase response. It should have good range of motion to permit people to again sit on the floor, squat. It should be simple to use. It should interface with the technology that exists. It should have good cosmesis. It should be robust, of course. So that's a prerequisite too, considering that the environment that people use artificial limbs in India are extreme. And again, it had to be affordable. Now, after studying, reviewing all the commercially available prosthetic designs varying widely in function, complexity, and cost, we zeroed in on the polycentric concept. Why the polycentric concept? For the simple reason that the human knee is polycentric. Just like when we were designing the foot, we wanted to replicate the human foot. When we started working on the knee, we wanted to take all the information that we needed from the human knee. As you can see here, those dots are, you see the human knee, during flexion and extension, the center of rotation that it goes through varies. And that's why the polycentric knee. Now, the polycentric knee, the concept is at least half a century old. It is energy efficient, it is biomimetic, and it is very versatile. But to make a polycentric knee, there were also a lot of challenges that needed to be overcome. Namely, it was a complex design, it was expensive, the existing polycentric knees were heavy and required maintenance. So the first prototype of the Jaipur knee was made in 2008. It consisted of two body blocks, the proximal and distal body block, two side linkages, one mid linkage, and it had two threaded portions, one proximal and distal, for attachment to the socket and the pylon. It was made of oil-filled nylon on a CNC, and the range of motion was 0 to 165 degrees, which is more than the traditionally available, very expensive knee joints that are being used. The Jaipur knee was hailed by the Time magazine November 2009 issue as one of the 50 best inventions of the world for that year. I'm speaking at IIT Chennai, and in all modesty, I would like to say that this is the only product featured in the Time magazine coming from India. So After all conventional lab tests like the finite element analysis, stress, wear, fatigue, failure, the Jaipur knee was put out for field trials. The initial response of stance phase stability, ease of flexion and swing, range of motion, and general acceptability was very encouraging. But again, as the trials progressed, we started encountering failure. Now that's the paradox. Failure in a product that was hailed by the Time magazine as a great invention, it failed. It failed on both counts. From our perspective, the threaded portions started wearing, the limbs started rotating in either external or internal rotation. And with prolonged use, the threaded portions even started just giving way and breaking completely. After the initial enthusiasm wore off, even the patients started complaining about the design. They started having concerns. Firstly, they felt that the cosmesis left a lot to be desired. Now, the foot had a square cross-section, and there's nothing in the human body that's square. So it really stood out like a sore. The bolts and the side linkages were very bulky. At terminal stance, the knee always made a clicking sound. Now, engineers from Stanford told us that clicking sound, it was haptic feedback, and it would be very good because patients will know that now the knee is stable. But engineers don't know patients. And we know our patients. And we knew that if we gave them a device that made a sound, clicking sound, and it announced their arrival before they did, they would not accept it, and which is what happened, they didn't accept it. So we had to go back and redesign the knee. In 2013, we were very fortunate in partnership with DREV, a not-for-profit company started by alumni from Stanford. We got the Indo-US Science and Technology grant, and the Jaipur knee underwent complete transformation. A socket interface was added to allow for dynamic alignment, noise dampening bumper to take care of the haptic feedback that the engineers wanted. We added an integrated extension spring for stability, updated pylon because the threaded portions were breaking, streamlined cosmesis, and it was designed for mass production. Now, this knee joint underwent the ISO 10328 testing, and it conformed to those standards. It was made in an ISO 13485 facility. But when it was put on field trials, it failed. In the first 50 patients, we had 44% failure in an ISO 10328 certified product. I must make a point here that lab tests are not truly representative of ground reality. And again, we had to send the knee back. Material changes were made, some design changes were made. It again underwent the ISO 10328 testing. And fortunately, after that, we've had a good run. The knee joint has been used in 12 countries, and it costs $80. It's made of acetyl polymer and is injection molded. We have the BTS 3D motion analysis lab at our center, and we use it for comparative studies. And this is a report of a left transfemoral amputee. And I don't know if you can really see the figures, but if you are interested, I can show you after the presentation. The figures for the amputee are very close to that of the sound limb, as well as well within the normative range. These are some of our patients using the different versions of the Jaipur knee. As you can see, they flex the knee and it's... This is Joe. He came all the way from Philippines for fitting of the Jaipur knee. He was used to using a single axis knee joint with a lock. Hence, he's still circumducting a little because it's very difficult to untrain a person in his gait pattern. Now, there are three key components in a lower extremity prosthesis: the foot, the shank, socket shank, and the knee. And on all three counts, the Jaipur limb technology is distinctive. We have the Jaipur foot, the Jaipur knee, and the HDP socket and shank. Our research partners are Stanford University, MIT, Santa Clara, Strathclyde, and De Montfort, and we continue to innovate and make more efficient products to enhance user performance. How does what we do affect people's lives? We know that disability disproportionately affects the vulnerable. Disability is inextricably linked to poverty, and prostheses are a gateway to opportunities, to inclusion. When we give an artificial limb, we don't just restore the mobility of the person, but we give them the opportunity to access education, to access employment, and as a result, become financially productive and socially included. So the impact goes way beyond just being able to move. And that's why, now disability is viewed in a much wider perspective. When you're talking about giving any assistive device, the ultimate goal is to improve the person's quality of life. So we got the Indian Institute of Health Management Research to study the impact of the Jaipur limb. They picked out 32 parameters, and they made these 4 indices. And the results showed that the Jaipur limb considerably, very significantly enhanced all the indices. This can be a presentation by itself, so I'm not going to go in details here. We added durability as part of the study too, and the Jaipur limb was found to last for 3.89 years, which is nearly a year more than the international standards, which are 3 years. So far, since inception to March of 2023, we have provided 707,000, which is 707,000 limbs in India. We have 31 centers across the country. And I must add that since we serve a large proportion of people from the bottom of the economic pyramid, all our services are free to the patient, whether it's limbs or calipers or crutches. These are some of our patients. I must elaborate on this slide. Motorbike accidents are the #1 cause of amputations in India. And when these young men come for prosthetic fitting, and we ask them, what are their expectations of the prosthetic limb? You will be amazed. Even before they talk about walking, they want to know if they can go back to riding a bike. And of course, I always say yes, for which I think the parents don't like me at all. This is Dodaram. He was born a farmer, lost his limb, and stopped being one. But with the Jaipur limb, he went back to doing what he loves best. He is one of our star amputees, and we use him a lot for peer counseling. Very spirited guy. So Dodaram is a veteran, and Ram Nivas was the first-time patient who had been fitted, and here he's counseling him. In fact, Dodaram is telling him that he can even climb a tree. And I had to stop him, that, it's his first time. Just don't get ahead of yourself, don't be so ambitious. But clearly, his bar was much higher than mine. Like I said, the knee permits 0 to 165 degrees of flexion, so people can adopt postures that are native to them. This is Pramod. His life is an ongoing adventure. You can see him rappelling at the Kedarnath. Impact does not always have to be tangible. In fact, more often than not, it is not tangible. When we talk of inclusion, this is the best kind of inclusion. Look at him taking on such a challenging trek with his able-bodied friends. I think it's great impact. But then, I don't think we can give all the credit to the technology. because technology is only an enabler. It is actually the indomitability of the spirit of these people that they're able to do these feats. Otherwise, most of us sitting in this room have our legs intact. And how many of us have done the kind of things that these people are doing? So it's really the person. This is Pankaj. He's a mechanic, and he loved just working on cars. Now he has his own workshop. These are some of our very complicated, challenging cases. Very poor. This is Madhu, also lost all 4 limbs because of electric burns. His father has a cycle repair shop near Hyderabad, in a village near Hyderabad. He is a very gifted painter. In fact, he featured on television with superstar Chiranjeev. And he drew his portrait with his mouth. He's a mouth painter. This is Lavyansh. Cadbury's did an ad on us on Rakhi. This is Lavyansh. He featured in that ad. Jafar was born without all 4 limbs. His father runs an auto in a place, in a village near Raichur. Last year,
मारो
now believe it or not,
वैसा मारो
the bike is
मारो मारो सीधा ले जाओ
Now, although the Jaipur foot was designed to meet the unique needs of Indian amputees, the designs that evolved have universal application. The Jaipur foot is currently being used in over 41 countries. We fitted 42,000 patients across these countries. In fact, this is a government of India, through the Ministry of External Affairs, a goodwill initiative from India to war-ravaged countries. And you can see there's Afghanistan, there's Iraq, there's Syria. They're all war-ravaged countries, very challenging initiatives. In fact, as I speak, our team is in Iraq fitting limbs. So these are patients in different countries. She was Miss Senegal at some point. This is Iraq. This is Palestine a month ago. And you can see these patients. This child was fitted the day this video was made, and you can see how he's performing. So requires very little training. This is Florencia from Mozambique. She was a teenage single mother who was brought by an organization from the US to Jaipur. We fitted her an artificial limb. She came to us very depressed, but she came back after 2 years to be trained as a prosthetic technician. In fact, her story is so interesting that John Mullen and Douglas wrote a book on her, which was launched in one of the most sought after and highly rated literature fests, that is the Jaipur Literature Festival, and it's available on Amazon. This is Donat. He was found begging on the streets of Rwanda by a German teacher who told the story to his friend in Austria, who I had met at the Zero conference. He reached out to me. I reached out to my friend in Mozambique who has a disability center. He didn't have the facilities. Then I reached out to another friend in Kenya. So neither did Donat come to India, nor did I go to Rwanda. But like they say, there is this law of 6 degrees of separation. If 6 right people get connected, they can make anything happen. So 6 people from 5 different countries who had never met each other, and you can see how Donat went from begging on the streets to becoming a tailor at a center in Rwanda, and he's now supporting his mother. Kenya and the rest of Africa was so indebted to the work Jaipur Limb has done that they issued a stamp to commemorate the Jaipur foot. Finally, with 85% people still waiting for prosthetic devices, there is a compelling need for research in prosthetics. But the research needs to be immersive. People working on prosthetic technology need to work with doctors, end users, service providers, be coherent to the needs of people so that you match technology to people and not retrofit people to the technology that you've developed. Although we work for low resource settings, I urge you, let quality and not low cost be the driving force. Be cost effective, but don't let inexpensive and low cost be your USP. The Jaipur Foot Organization, BMVSS, we strive to indigenize, innovate, demystify, and decentralize prosthetic services and prosthetic design. I invite you all to visit us, see our work, share your ideas, and even partner with us so that all may walk. Thank you.